Hello viewers, welcome back to our channel GPSC Network. Friends, today we will be discussing the paper of GPSC for the post of Assistant Inspector Motor Vehicle Class 3. This question paper was taken on July 21st, 2019. So in this video, we will be covering the question paper solution and detailed analysis for the same. So question paper was having around 300 questions. So we have divided each video of 50 questions. So there will be 6 part of this all question paper. Before that, let me introduce myself. I am Viral Mevcha from GPSC Network. If you want to contact me or if you have any doubt after video, then you can contact me through the social media handles of GPSC Network. One more thing I need to tell you that solution for the same will be available on website. You can find the link in the description box. So let's start with the question number 1. According to perpendicular axis theorem, moment of inertia of a planar body about an axis perpendicular to its plane is equals to the blank of its moment of inertia about two perpendicular axes concurrent with the perpendicular axis and lying in the plane of the body. So here what you need to find out is the moment of inertia, right? And if you read the statement, then it is already a perpendicular axis theorem. So if you know the perpendicular axis theorem, then it is I is equals to I xx plus I yy. Means what you need to have moment of inertia with respect to two plane or with respect to two axes, right? So if you have this moment of inertia, then you can add it up and you will be able to find out the moment of inertia of total moment of inertia of a plane body, right? So here you can see the sign is of sum, right? So answer should be C. Now let's move to the second question. Center of gravity of solid right circular cylinder of base radius r and length l is blank from each of the flat faces. So it's very simple question from the engineering mechanics. Let me draw one cylinder so it would be very easy to understand. Here the length is given as an L. L is the length and the radius is R. Cylinder is given as a solid right circular cylinder. So you can assume that center of gravity should lie at the exact center, right? Now if you want to find out the center of gravity in terms of base radius and length L, then it would be either you can write it down as a r by 2 or l by 2, but here what they have asked is you need to find out the center of gravity from each of the flat faces, right? So from the flat faces, I have one flat face, another face is at the bottom. So from top and bottom you can consider the center of gravity in terms of L or length is L by 2, right? If they have asked in terms of that cylindrical face or cylindrical surface, then answer should be C, right? Here they have asked from each of the flat faces, so answer has to be L by 2. Let us move to the question number 3, that is condition for maximum efficiency of a screw jack is blank. So if you know the theory of a screw jack, then you can give directly the answer that helix angle alpha is equals to 45 degree minus uh, that is angle of friction phi by 2, right? So alpha is a helix angle, right, and phi is angle of friction. So you can give directly the answer, that is A, right? Helix angle in degree is equals to 45 degree minus angle of friction in degree by 2, right? So that would be the answer for the condition for maximum efficiency of a screw job. Now question number 4, here they have given that if alpha is denotes as an helix angle, here we have already taken, and phi is the angle of friction, right? Then the efficiency of a screw is given as, right? You need to find out the efficiency of screw, right? So if you know the equation directly, then you can give the answer. But if you want to understand the theory, let me draw one of the thread here like this. Length of the thread, that is pi d in terms of a mean diameter, and here it is the pitch p, and the alpha, that is a helix angle. Now you should also know the raising load, that is P is equals to W 10 alpha plus phi. This equation you should know, right? Now if I want to find out the efficiency, then I can relate the term with respect to friction, right? Here you can see the alpha is an angle of friction. So if I make friction is equals to 0, then this equation would become P0 is equals to W10 alpha, right? What I have done, alpha is equals to 0, I have taken it, right? So this is a pure imaginary condition, right? So that we can find out the efficiency. So equation for efficiency would be equals to eta is equals to P 0 divided by P, right? So P0 is a W10 alpha divided by W10 alpha plus phi. So if you want to write or further derivation wants, then you can remove the W, right? So it would be 10 alpha upon 10 phi plus alpha, right? So the answer you can see here, a D 10 alpha divided by 10 alpha plus phi, right? That would be the uh, efficiency, that would be the efficiency of a screw, right? Let's move to the question number 5. If the velocity of a body is doubled, its kinetic energy. So it's very simple question, that if you know the equation of kinetic energy, then K is equals to 1 half mv square, right? So here K is the kinetic energy, m is the mass of the body, and v is the velocity, right? So if I want to find out the new kinetic energy, let's say it is K1, then it should be 1 half m will remain same because the body is same, and velocity is getting double, so 2 of v, right? So it would be 4 into 1 by 2 m, so it is v square again. So here 1 by 2 mv square, that is a k, right? So you can see that new kinetic energy K1, that is equals to 4 of the previous kinetic energy. So it gets 4 times or becomes 4 times. So the answer should be D. Now let's move to the question number 6, right? If bar of length L, capital L meter, extends by small l millimeter under load W, the strain is S. Very simple question if you know the equation of strain. So let me explain. Strain is equals to change in length divided by original length, right? So here the change is given, that the bar is getting extends by small l millimeter, right? So a small l millimeter, if you want to convert that into meter, right? Capital L is in a meter, so you can convert that change is equals to 0.001 small l, and the original length is already capital L. So answer should be uh, 0.001 into small l divided by capital L. So that would be the strength, right? And the answer should be B. Now let's move to the question number 7. Which cutting condition affects the cutting temperature predominantly, right? Actually everything, right? Or what is your cutting condition? Based on cutting condition, it affect the temperature, right? Cutting temperature. But here what they have asked is uh, which cutting condition affects cutting temperature predominantly, right? So depth of cut is there, then feed is there, right? Cutting speed is there, right? These three things affects the cutting temperature. But if you understand the practical, right? If you have performed the practical, then you will be able to find that the cutting speed is affecting the cutting temperature predominantly, right? It's based on practical, right? There is no theoretical proof currently. Let's move to the question number 8. That is, lathe bed is usually made up of. So, if you consider the application of a lathe bed, then you will be able to understand that lathe bed is usually having a higher compressive load, and second is it is used on a very high vibration condition, right? So we should use such a material which can take up the high compressive load, and which is also useful for the damping purpose, right? So in this options, you can see the copper is given, stainless steel is given, cast iron is given, and mild steel is given, right? So out of this, uh, copper, stainless steel, mild steel, all these are the ductile material, right? Which can be useful for the tensile load, not for the compressive load, right? So only one option is there, that is a cast iron, right, which is having a good damping characteristic. That's why we can use cast iron as a material for the bed, right? C should be the option, or C should be the right answer, you can say. Now let's move to the question number 9. Which of the following machine is useful for the machining surface if the size of the job is large? So which of the following means you can see the option first, right? They have given a shaping machine, then planing machine, slotting machine, and none of the options. So out of that, only two machines you can see, that a shaping machine and the planing machine, which can be useful for the machining surfaces, right? So other two options we need not to consider, right? Now what they have asked for, if the size of job is large, right? So shaping machine cannot be useful when the job size is very large, so the answer should be B, right? Planning machine is useful for the very large job, right? In shaping machine, what happens, your tool, right, tool is moving while job is fixed. On a table. Number 10. Internal keyways in gears can be cut by using dash. So option number 1 is swapping machine, B planning machine, C slotting machine, and D none of the options. So from options you can see that swapping machines and planning machines, these machines can be useful for working on the job surface, right? if you want to work on the surface, you can use shaping machine and planing machine. And slotting machine can be used to cut the slot on an inside surface, right, or outside surface. So internal keyways in gears can be cut by using the slotting machine. So answer should be C. Question number 11. The collection efficiency of flat plate collector can be improved by. So if you know the theory of flat plate collector, then you can get the idea that flat plate collector is uh, used for the water heating purpose, right? And there are extensive research on that. If you work on a glazing area, then you can improve the uh, collector efficiency, right? So if you see the options, then A option is putting a selective coating on the blade, so it is available, right? By that way you can improve the efficiency. Then second one is evacuating the space above the absorber plate, that is also one of the options to increase the efficiency. And C is both by putting a selective coating on the plate and evacuating the space above the absorber plate. And last option is none of the option. So here you can see the C option would be right. uh, by both these ways we can able to improve the efficiency of flat plate collector. Number 12. In case of a hydropower plant, pressure variation in the penstock are taken care of preventing water hammer by test A draft tube, then B surge tank, C pump, and D is a penstock. So here what you need to do, you need to prevent a water hammer in the hydropower plant, and which is caused by a pressure variation, right? So you need to use such a device which can be useful for the damping and as a pressure relief, right? So from options you can see the surge tank can do this work, right? So the right answer should be the surge tank. Number 13. 4 bar mechanism has at least one revoluting link if the sum of the lengths of the largest and shortest link is dash sum of lengths of the other two links. So here the options are twice, greater than, less than, and none of the options, right? So if you know the theory of a double rocker mechanism and triple rocker mechanism, then you will be able to have the answer for the same, right? If I draw for the double rocker mechanism, and for the same it would be shortest plus longest will be less than other two links, means P and Q. And if I write it for the triple rocker mechanism, then it would be shortest plus longest would be greater than other two link, right? So here you can see that they need at least one revoluting link, right? So that mechanism would be double rocker mechanism. And for that you can see the answer should be the sum of shortest and largest and shortest link is less than the sum of other two links, right? So if you see the options, then C should be the answer, that would be less than, right? Number 14. The linear velocity of point B on a link rotating at an angular velocity omega relative to the another point A on the same link is. So if you know the equation to find the linear velocity in terms of angular velocity, then it shows as v is equals to omega into r, right? Where r is the radius, omega is an angular velocity, and v is the linear velocity. So if you write down for the link, right, then you can write it down as a v is equals to omega into AB. Here I have written as an AB because you want to find the relative velocity of point B respect to point A, right? So you must have a difference or a distance between these 2 points, right? That is AB. So the answer should be B, that is omega into AB. Question number 15. The Coriolis acceleration component is taken into account for a mechanism. One, a four link mechanism, quick return mechanism, and third one is a Scorchock mechanism, and last is a none of the options. So the Coriolis acceleration component should be taken into account for such a mechanism where one point on a link which is sliding along the one link and respect to the another rotating link, right? At that time we should consider the acceleration component, right? So if you see the option 4 bar link mechanism, then sport yoke mechanism, in these mechanisms we do not have such condition, right? But in quick return motion mechanism we have a point on a link which is sliding along the rotating link, right? So that's why the answer should be B, right? In quick return motion mechanism we need to consider the Coriolis acceleration component. Question number 16. In an internal expanding brake, which of the following is a self energizing shoe? So if you know the definition of self energizing brake shoe, then you will be able to have some idea. A brake shoe that applied which develops a wedging action, and it actually assists or boosts the braking force by the applied by the wheel cylinder. So that would be the definition for the self energizing brake shoe, right? And here they have asked for the internal expanding brake, so the answer should be leading shoe, which will work as a self energizing shoe in the internal expanding brake. So C should be the answer. Question number 17. In a end plate multi-plate friction clutch, the number of active friction surfaces is equals to. So it's very easy question, that number of active frictional surface is always one less than that of number of plate, right? So here the number of plate is given as an n, so the number of active friction surfaces would be equals to n minus 1, so the D should be the answer. Question number 18. Static balancing involves balancing of. So here the body is already in a static condition, there is no relative motion, right? And so there is no need of any couple, right? There is no generation of any couple. So from options you will be able to get that forces has to be answer, right? Forces as well as couples, and none of the options. These are the options they have given. So out of this, forces should be the answer, right? Because they have considered only a static condition and a static balancing. Question number 19. In case of rotating masses, the magnitude of the balancing mass is blank when the speed of the shaft is double. So here the question is, we need to find the relation between the magnitude of balancing mass and speed of the shaft. So here you can say that magnitude of balancing mass doesn't relate to the speed of the shaft, whether it is doubled or decreased or whatever way we change it, right? It remain unaffected, right? So the answer should be C. Question number 20. For complete dynamic balance, at least blank mass or masses are necessary. So it's very easy to answer that we will require at least two mass to have a complete balance in a dynamic condition. So the answer should be B2. Question number 21. The governor is said to be dash when the speed of the engine fluctuates continuously above and below the mean speed. So if you know the definition, right, that hunting is a result of two sensitiveness of the governor, and it causes continuous fluctuation in the engine speed above and below the mean speed. So if you know the definition, then you will be able to have answer, and that would be the D. Hunting should be the answer. Other isochronous insensitive stable, by that these are the other terms of regarding the governor that you can refer. Question number 22. In vehicles, the flywheel is placed between. It's very easy question that where we should place the flywheel. So flywheel is placed between the engine and clutch, that everybody knows. But you should know the function of flywheel, which work as a reservoir during the third stroke power stroke. If you consider the four stroke engine, right, and during the other strokes we will use that stored energy, right. So the answer should be A, engine and clutch. Between engine and clutch we will place the flywheel. Question number 23. In force vibration, the ratio of steady state vibration amplitude to the static amplitude of the motion is called as. So the options given: magnification factor, resonance, static deflection ratio, and none of the options. So from the definition they have given a ratio of a steady state vibration amplitude to the static amplitude that shows the magnification factor. So the option A should be the right answer. Question number 24. In a spring mass system, if the mass is halved and spring stiffness is doubled, the natural frequencies. So if you know the equation for finding the natural frequency, then you will be able to find out the answer, right. So if I want to write down Fn is equals to 1 upon 2 pi under root of k under k upon m. So here what we need to do, spring stiffness is to be doubled and mass is to be halved, right. So let's implies that 1 upon 2 pi remains constant, k is to be double, so 2k, mass is to be halved, so m by 2. This 2 will go up, so it will be 1 upon 2 pi under root of 4k by m. So again 4 would come out, so it would be 2, 1 upon 2 pi under root of k upon m. So it would be 2 into Fn, right. So the initial frequency was Fn. So if you double the stiffness and um, mass is half, then the natural frequency would be double. So D should be the answer. So question number 25 and question number 26, both are the definitions only, so there won't be any explanation, so we just need to go through the questions. For question number 25, for flywheel, the ratio of maximum fluctuation of the speed to the mean speed is called. So this ratio is called as a coefficient of fluctuation of the speed, right. So C should be the answer. Then question number 26, the number of revolutions or hours at a constant speed that 90% of a group of nominally identical ball or roller bearings will achieve or exceeds before the failure criterion develops is called as a. So that is also a definitions. So here the answer should be rating life of the bearing, right? A should be the answer. Question number 27. Two shafts A and B are made of same material. The diameter of shaft A is twice that of shaft B. The power transmitted by shaft A will be dash of the shaft B. So it's very easy that if you know the relation between the power transmitted by shaft respect to the diameter, then you will be able to have an answer. Let's write it down. Power P is proportional to d raised to q. So here the power uh, transmitted by A that you need to find out, right? Here the diameter of shaft A is twice that of a shaft B, right? So if I write it down as a 2d cube, then it would be 2 raised to 3, so it would be 8 into d cube, right? So here you can easily relate that power transmitted by shaft A will be 8 times that of shaft B, right? So answer should be C. So question number 28. Ignition quality of a diesel fuel is indicated by its dash octane number, C10 number, fire point, and none of this. So if you see the question number 29, 30, and question number 28, all these are of a theory based question, so there won't be any much explanation, right? You can have a direct answer based on understanding or your remembering thing, right? So the first question, right, 28, ignition quality of diesel fuel is indicated by its C10 number, so B should be the answer. Then question number 28, stoichiometric air fuel ratio of petrol is roughly 15 gen 1, 15 gen 1, right? So here 15 would be the related to air, 1 is related to fuel, right? Then question number 30, in a conventional battery ignition system, ignition coil is consist of dash winding coils. So total number of ignition coils would be 3 in a battery ignition system. So answer should be B. Question number 31, which of the following methods is used to determine engine friction? So again question number 31 and 32 both are related to the theory, right? So we can have a direct answer. Okay, so here in 31 the options given indicated and brake power measurement, then Morse test, and wheel and lines method, right? So these are the three methods. All methods are used to determine an engine friction, so we can directly give an answer. All of the options is right, so D should be the answer here. The question number 32, relative efficiency or efficiency ratio of an IC engine is the ratio of dash thermal efficiency of actual cycle to that of ideal cycle, then second thermal efficiency of ideal cycle to that of actual cycle, mechanical efficiency to volumetric efficiency, and none of the options. So here if I want to write down, then efficiency, right, of efficiency thermal is equals to efficiency actual divided by efficiency ideal, right? So that should be the equation to find the thermal efficiency or relative efficiency. So A should be the answer. Question number 33 and question number 34, both question are theoretical based question, so we would not go in a detail, right? So slip joint in a propeller shaft is provided. So here the slip joint in propeller shaft is used to uh, provided to maintain the length, right? So B has to be the answer. We don't go in a detail. Then question number 34, torque loads during the acceleration tend to the front of vehicle to be lifted. This effect is called as a squat, right? So A should be the answer. Similarly, you can go for the deep rolling, cornering, right? These are the things you can refer to. Question number 35, to accommodate change in length of the leaf spring, one is connected with the help of this. So this one is a pure knowledge based question. Then Sekel is used to do that, and so Sekel will be able to accommodate the change in length of the leaf spring. So D should be the right answer. Then question number 36, steering ratio refers to the ratio between the turn of dash. So here also this one is a theory based question. If you know the data, right, and if you can recall the thing, then this would be very easy. Steering ratio is the ratio for the turn of the steering wheel divided by the turn of the wheels, right? This both ratio will be taken in a degree, so A should be the answer. Question number 37, if the Reynolds number in a pipe less than 2000, the flow is said to be dash. So Reynolds number greater than 2000, the flow is turbulent. Reynolds number is equals to is less than 2000, then the flow is laminar, right? So that's the thing you should know, right? And the answer should be laminar. Then question number 38, Bernoulli's theorem states that in a steady ideal flow of an incompressible fluid, the total energy at any point in the fluid remains constant. So that's the law of Bernoulli, and it's a means total energy remains constant. So A should be the answer. So question number 39, the momentum equation states that the net force acting on a fluid mass is dash the change in momentum per second in that direction. So from options you can directly say that the answer should be equals to B should be the answer, because equation of the force you can say it is equals to F is equals to M into U1 minus U2. So here uh, if you want to find out the net force acting on a fluid mass, then is equals to that the change in momentum per second. If you want to write it down in a per second, then you can say it is u1 dot and here also u2 dot. So change in momentum per second in that direction, right? So it should be equals to, and the B should be the answer. Question number 40, the line which gives the sum of pressure head, datum head and kinetic head of a flowing fluid in a pipe with respect to some reference line is called as. So this three head, when we add these three head, right, pressure head, datum head and kinetic head, that will give you a total energy, and that line will referred as a total energy line, right? So it is B should be the answer.